Good morning. So yesterday in previous class I discussed relational algebra and also relational calculus. Now today our topics are renaming, joins, division. More examples in that joins and divisions, and relational calculus, tuple relation calculus, and what is the difference between tuple relational calculus and domain relational calculus. So these topics I have to discuss. So yesterday I discussed these operations, basic operations. I also gave the examples on these selection, projection, cross product, self differentiate, and union operations. So actually, first of all, what is the relational algebra? Relational algebra is a procedural language. Okay, it is a procedural language. So simply it is a operational language. So here main another operations, intersection, join, division, renaming concepts also introduced in yesterday class. So now here again I have to take this example: R1 table, S1 table, and S2 table. So for suppose first joins. Okay, what is the join? What is the join? So see these tables, these three tables, examples. Only take the examples. R1 table, this is the reserve table, this is the Sailor table 1, and this is the Sailor table 2. So here first join operations. What is the purpose of join operations? So for suppose reserve table is there and Sailor table is there. So join means combine one table combined with another table. So that is called join. By using join operator, this operator is nothing but join operator. This is also called natural join. Okay, so this operator is join operator. So see the table, the condition is S1 table from S1 relation, this is a join operator. So here S1 from S1 table, SIDs, Sailor IDs less than or less than reserve table SID. So see the table, check the condition. Condition is S1 join operator. So condition is S1 ID less than R1 ID. So here see the table, R1 table, S1 table, only less than values. So here SIDs, to check the SIDs. So here Sailor ID and in the reserve table SID. This is a Sailor ID in S1 table, in the reserve table Sailor ID. So in the reserve table S1 less than R1. So check these two tables. So here this is the reserve table, this is the Sailor table. So S1 less than R1. So here S1 less than R1. So only 21. So 58 is a greater than. So S1 less than R1, only two values, 22, 31. So this data will be added. So both tables, check both this SID, BID and boat ID day. So here SID, SName, rating, age. So from these tables, so join S1 less than R1, only IDs, check the column SID is 22, 58. From seller table 1, SID is 22, 31, 58. So here the condition is S1 less than R1. So R1 is from R1 22, 58. From S1 22, 31, 58. So only to check the condition, less than condition. So S1 less than R1 only from column of SIDs. So only two tuples, that is 22, 31. So this is the greater than. Okay, 58 is a greater than. So here two tables are combined. SID 22, 31. So same SID, S name, rating, age. This is this table, and add R1 table. SID, BAD, date. Okay, that is the example for join. Next, another condition, another a special case of condition join where the condition C contains only equalities. Here only equalities means, so here the 22 SID 22 is there in this R1 table. In S1 table 22 is there, 22 same equalities 22 SID here, and also S1 table 22 is there. So here names are different, okay, but name is same. SID here, SID name is Dustin. These are the these are the properties, rating, age. Okay, so here by using this one only, in this only equalities. Okay, SID 22. Okay, SID 22. Only two SIDs are there in each table. So only takes the one value, one SID. Okay, next. So result schema means enter data, result data similar to cross product. This is also similar to cross product, but only one copy of fields for which equality is specified. Okay, next. So what is the natural join? This is the natural join operator. So already yesterday I explained this division. So what is the division? You know, regarding division. So here this is not supported as a primitive operators, but useful for expressing queries like find sailor who have reserved all boats. Okay, if three conditions are in A by B, by is a division operator. So the attributes in B must be included in the schema for A. Also the result has attributes A minus B, sales to products to relation sales, and products must be built using productions. So here check the examples. Already in previous class I discussed these topics. So here, so see this table, A table, see the A table. So this is the B table, this is the B2 table, and this is the B3 table. This is the B3 table. Here we are using operator A by B1 and A by B2 and A by B3. Here, for suppose if you want to data A by B from the relation means table. So here A by B1. Here in the B table, P number P2 in this field, P2 value. Okay, so P2 A divided by B1. So here what are the P2 values? P2 values here and here, here and here. Okay, so S1, S2, S3, S4. So the result of schema is S1, S2, S3, S4. Okay, this is A by B1 table. This is A by B1 table. And coming to A by B2, is, so here P2, P3. So P2 S1 value, check the serial number. Okay, and P4, where is the P4? P4 is the S4. Only S1 value and S4. Okay, this is the resultant of A by B2 is S1, S2. Okay, next coming to the result of A by B3, A by B3. So here B3 fields are P1, P2, P4. Here P1 S1, P2 S1, P4 value S1. But same time P1 value S2, P2 value S2 and P4 value S4. So these are the different values, but here the starting values of P1, P2, P3, okay, is S1. So that's why, for suppose if you are dividing A by B3, the same values for different these fields, then only S1, only the P1 is S1, P2 is S1, P3 is S1. The result of A by B3 is S1. Okay, the result of A by B3 is S1. So this is the division operation. Okay, some remaining examples are there. Suppose division is not essential operator, but just is a useful shorthand. Okay, so also true of joins, but joins are so common that systems implement joins specially. Division is not implemented in SQL. It is not implemented in SQL. Okay, it is not an essential operator. Okay, next this is for suppose query is A equal to, this is the projection operator, projection SID. So to project the sailor IDs, and here the query is projection sailor ID sales into products. Okay, this is the cross product operation, and minus sales. Okay, this is the set operations. There is the answer is project SID sales, minus A. This is the set operation A. Okay, only differentiate sailor IDs and A. Okay, this is the resultant. This is the result for this query. Result for this query. Okay, next the main another topic is tuple relational calculus and domain relational calculus. What is the tuple relational calculus? Okay, tuple relation, actually relational calculus is a non-procedural language. It is a non-procedural language. Relational calculus is a procedural language. Okay, sorry, relational calculus is a, relational algebra is a procedural language. Relational calculus is a non-procedural language. Here there are two calculus you have to discuss. One is tuple relational calculus, another one is domain relational calculus. So here first tuple relational calculus. What is the tuple relational calculus? Already I said to you, it is a non-procedural query language which specifies to select the tuples in a relations. Okay, it specifies select the tuples in a relation. Relation is nothing but it is a table. So here the main selecting the rows from a table, that is called tuple relational calculus. Okay, simply says for tuple relational calculus is simply selecting the rows from the table, that is called tuple relational calculus. Here it can select the tuples with a range of values or tuples for certain attribute values extra. So the resulting table can have one or more tuples. Okay, so tuple relational calculus notation is, so here T by T. This is the specification for T, with P of T. Okay, or T condition of T. Here where T is the resulting tuples, where T is the tuple means row. Okay, remember it. Okay, tuple means it is a row. So T is where T is resulting tuples and P of T is condition used to fetch T. Okay, that means to select the rows. P of T is select the rows. Okay, example here, T employee of T and T dot department ID is 10. Department, that means that meaning is department 10. So actual meaning of this statement, this is select all the tuples of employee name who work for department 10. Okay, this meaning is this select for this query entire statement of T or employee of T and department ID is 10. That the meaning is this select all the tuples of employee name who work for department 10. Okay, next, domain relational calculus. So here a domain relational calculus uses list of attributes to be selected from the relation based on the conditions. Okay, mainly it is also non-procedural language. Okay, domain relational calculus is also non-procedural language. Simply, a domain relation calculus uses a list of attributes, but tuple relation calculus, tuple relation calculus is selecting the rows or selecting the tuples. Here, list of attributes. You have to select the list of attributes from the table. Okay, based on the condition. Main difference is in tuple relational calculus, selecting the rows from the table or from the relation. Here, domain relational calculus is to select select the attributes from the table. That is the difference between tuple relation calculus and domain relation calculus. The definition for domain relation calculus is domain relation calculus uses list of attributes to be selected from the relation based on the condition. It is same as TRC. TRC means tuple relational calculus, but difference between tuple relation calculus and domain relation calculus is selecting the attributes rather than the selecting the whole tuples. Okay, selecting the attributes rather than selecting whole tuples. So here notation. Okay, A1 examples, A1, A2, A3 and so on, and AN and so on, AN. So here next P1, the condition P1 bracket A1, A2, A3 and so on, AN, where A1, A2, A3 and so on, AN are attributes of the table. Okay, P is the conditions. Okay, A1, A2, A3 and so on, AN, these are the attributes of the relation. Okay, relation means table. Okay, so next P is the conditions. This is called a domain relational calculus. So here example, employee department 10, selecting the employee ID and employee name of employees who work for department 10. Here the condition is selecting the employee. Okay, selecting the employee ID, okay, and name of the employee. For those who are worked for department 10, only department 10 employees, only department 10 employees names we need, department 10 employee names and IDs. Only we need employee ID of department 10 and also employee name of department 10. Okay, this is the tuple relational domain relational characters. Differences are, so these are the main differences. For suppose number of times they are asked in external examinations. So see the differences in tuple relational calculus. The variable represent the tuples from specified relations. In domain relational calculus, the variable represent the value drawn from specified domain. Okay, the first difference. And second difference, tuple is a single element of relation in database term. Okay, it is a row. Okay, tuple is a row. Domain is equivalent to column. Okay, only to select to concentrate on variable. To concentrate on attributes. Okay, a domain is equivalent to column data type and any constraints on value of data, that means attributes. Here in tuple relation calculus, in this filtering variables uses tuple of relations. Here in this filtering is done based on the domain of attributes. Okay, next one, notation. So notation is T by P. P is the conditions. Okay, T is the tuples. Okay, or T by this is T is the tuples, P is the conditions. Okay, here notation A1, A2, A3 are the attributes, P is the conditions. Okay, next examples, T by T is the tuple, employee of T and T department ID is equal to 10. So here they need only department ID 10, department 10 employee only employee row to display the employee IDs, to display the employees either name or IDs, to display employee names or IDs in that relation, that entire row. Okay, here for department 10 employee details, employee either like AS or IDs, anything. Okay, so both are same, but the difference is in this tuple relation calculus only concentrate on tuples. In this domain relation calculus only we need the attributes. Okay, the summary of our topics. The relational model has rigorously defined user query languages so that are simple and powerful. Already yesterday I am already this summary already discussed yesterday. Okay, the same topics and some topics are added in our today lectures. So here relational algebra, what topics are covered in previous class and this class? Relational algebra, relational calculus. In the relational calculus, some relational operators are discussed, relational operations are discussed like selection, projection and division and set operation. Okay, and conditional join. Okay, these topics are covered here. So it is a more relational algebra is a simply it is a query language. Okay, it is a Korean procedural language. It is more operational. Okay, next it is useful for internal representation for query evaluation plans. Okay, next several ways of expressing a given query. A query optimizer should choose the most efficient versions. Okay, most efficient versions. Okay, if you are having any doubt, and we will discuss in interaction session. Okay, please ask the questions. For suppose if you are not asking any questions, I can't able to tell you. Okay, can't able to give the explanations. All are asking questions regarding what you have learned. Okay, please ask the questions. Okay, thank you.